Let's talk about how we solve station 1 for the forces unit. Mass hanging from a red scale. Let's refresh our memories on what that picture looks like. Here you go. I've got a scale, and I have some amount of mass hidden in the box. That's this 1 on the left. Begin by drawing the force diagram. I can tell by looking at it that the box is at rest, therefore I've got a situation of balanced forces. So I actually started by realizing this. Then I started figuring out what the interactions between the box and its environment were. Started with the old reliable force of gravity by the Earth on the mass, that's a downwards force. Upwards is the force of tension by the spring scale on the mass. So this is the spring scale pulling up. This is the Earth pulling down. I know that these forces are balanced. I have labeled any abbreviations I've used that aren't like super duper common. I'm going to assume we all know E is for Earth at this point, for example. My force diagram is done. Note that all force diagrams must include not only the diagram part, but a statement of whether the forces are balanced or not. That is a required part of the force diagram. Now let's go to solving it. I'm supposed to determine the hidden mass value. It is important that you solve your problems in order, start to finish, top to bottom on your page. This is about presenting a clear solution to the reader. I recommend, from this balanced forces statement, turn it into an equation. So the net force is the tension minus the gravitation force, aka weight, and it equals 0. Balanced forces means equals 0. With that line done, I'm going to remember the value that I read off of the spring scale was 14 newtons. What force is that? Well, that's the interaction between the spring scale and the mass, so I've labeled it as tension. That's the reading on the scale. I just made a note there of that because I want to be clear. It's data I read. It's not a number I calculated, 14 newtons. I return to my original equation and I rewrite it, filling in the one value I just now realized I have. Because I am solving for hidden mass value and I don't have mass in this equation, I broke down force of gravity into mass times gravitational field strength. There's the M that I'm going to need. G, a constant here on Earth, is 9.8 newtons. So this equation here has in it all of my known values, and it has the only variable left in it, the unknown mass. This is now an algebra problem. I'm going to add 9.8 m over to the other side of the equation. 14 equals 9.8 m. I'm going to divide 14 by 9.8, and I get 1.4. And if I follow this up through my line of reasoning, I know the units have to be in kilograms because my mass was in newtons, and G is measured in newtons per kilogram. Mass should always come out to be in kilograms. This is a complete solution. Pay attention to the really important parts that we all need in every problem. Let me number them here. Force diagram, whether the forces are balanced, net force equation, and then whatever algebra gets you to the solution. In a box at the very end of the problem, you'll notice how my solution does follow top to bottom, start to finish, not all over the page. Thanks for watching.